Hi everyone, it's Iman. In this video I'm gonna give you a quick overview of FEMA P695, which is all about quantifying building seismic performance factors. Let's get started. Alright, this document has three main applications. First, it helps us determine seismic performance factors. These factors include the response modification coefficient, or R factor, the system overstrength factor, and the deflection amplification factor, or CD. Okay, these are typically found in ASCE 7, but FEMA P695 is especially useful when you're working with new or innovative structural systems that are not covered in ASCE 7. Okay, so you might ask, why use this even for systems already listed in ASCE 7? Well, let's say you want to study the effects of near fault ground motions or soil structure interaction on the performance of, say, a moment frame. Okay, FEMA P695 gives you a more accurate and system-specific way to calculate these factors, R or omega 0 or CD factors in those cases. Okay. Second, FEMA P695 provides a clear guideline for selecting and classifying ground motion records, specifically how to separate far field and near field records. This is super helpful when running dynamic analysis. Okay. Third, and this is a big one, it allows us to assess the collapse probability of a structure. To do this, basically, we need to run nonlinear time history analysis, which is called IDA, Incremental Dynamic Analysis, where a structure is subjected to a set of ground motions with increasing intensity levels to estimate its performance. All right, take a look at the left plot over here. These are the IDA results. The x-axis shows the maximum inner story drift, and the y-axis shows the spectral acceleration. Each curve here comes from one ground motion record. Okay, the pink line is the 50% fractal or median of all IDA curves. It basically summarizes the overall structural response. And then the black squares show collapse points based on a definition, either when the drift reaches 10% or when the slope of the curve drops to 20% of the initial elastic slope. Now, from all those collapse points, we find the median spectral acceleration, shown here as SCT. Okay, and SMT is MC ground motion intensity, which is defined using these equations and the table below, depending on the period of the structure. And then we compare SCT to SMT. That ratio gives us the collapse margin ratio, or CMR. Okay, and basically CMR is kind of the capacity to demand ratio. So the higher the CMR, the safer the structure is against collapse. So we list all the SA values at collapse and then take their median. So here, the median of all these values is 2.8, which we call SCT. And then let's say in this case, SMT is 1.1. So we divide 2.8 by 1.1, and that gives us a CMR of 2.5. So if an earthquake were to occur with a spectral acceleration equal to the MCE level, there would be a 50% chance that the structure would collapse. So the larger this margin, the safer this structure is. Okay. In this example, the collapse capacity is 2.5 times greater than the MCE level or MCE demand, which shows a good safety margin. Okay. Another application of IDA is determining the spectral acceleration corresponding to a given performance level. For example, IO level, LS, or CP level. For instance, for the life safety level in ASC 41, which may correspond to, say, 2% drift, the associated spectral acceleration can be identified using IDA results. Now, on the right, you can see how we use the IDA results to create a fragility curve. This shows the probability of collapse versus spectral acceleration. This figure shows an example of cumulative distribution plot obtained by fitting a log normal distribution through the collapse data points. The median collapse capacity, which is SCT equals 2.8 in this example, correspond to a 50% probability of collapse. Or if an earthquake has a spectral acceleration of 2g, the chance of collapse is around 20%. So again, the CMR gives us an idea of the collapse safety margin, but we also need to adjust it based on spectral shape effects, especially when near field records are involved. That's why FEMA P695 also defines the adjusted CMR, which takes this into account. And you'll find the details in the document. All right, thanks for watching. If you found this helpful, give it a thumbs up and don't forget to subscribe for more content like this.